relative atomic masses. When you see it in a bracket, you will see RAMS, relative atomic masses, becomes the new topic. Now, when we discuss about isotope, you find out that we discuss about this relative atomic masses, but though it was only in elements. But now, in this new topic, we are going to put into consideration that of the compound or mixtures, their relative atomic masses. If they ask you to calculate the relative atomic mass of calcium trioxocarbonate 4, magnesium trioxocarbonate 4, magnesium tetraoxosulfate, this and that. So anyone they ask you to calculate using this particular formula, the relative atomic mass, now you can quickly arrive at the answer. Now, as we have that of hydrogen tetraoxosulfate 6 is a compound or a mixture. We also have sodium hydrogen trioxocarbonate 4. We also have this as a mixture or a compound. We have calcium tetraoxosulfate 6 also as a mixture. We can also have magnesium tetraoxosulfate 6. We also have potassium trioxocarbonate 4. All these are mixture. But if they ask you to now calculate their relative atomic masses, how do you go about it? So you quickly move by understanding the element involved. Now, if I want to simplify this to you, you are going to see here, in some cases, they will give you the atomic mass of the elements involved. In some places, they will put brackets. They will put brackets if they ask you to calculate the relative atomic mass. Let us just take this number 1, number 2, number 3, then number 4, and number 5. In this number 1, you are going to see hydrogen equal to 1. They will give you like that, comma, X, which is sulfur, equal to how many? 32. While oxygen, they will put it equal to 16 and close the brackets. But if you don't know it, you don't know how to make use of all this in that. But giving you this is like giving you the whole of the expo. Ordinarily, as a scientist as you are, you need to have them off heart. You need to, if it is by cramming, but I don't encourage you to cram. If it is by cramming, you're supposed to make sure that all the mass number are in your brain. So now, having given you this, I'll quickly go by this way. Now I'm picking number 1, hydrogen tetraoxosulfate 6, to calculate its relative atomic mass. Solution. Then I have hydrogen tetraoxosulfate 6. Then I'm going to have hydrogen. They have given me the mass number as what? 1. Therefore, I'm going to have 1 times 2, because this 2 is affecting hydrogen only. So 2 times 1, then I'll put my plus. And I'm going to have S. What is my S there? My S is what? Sulfur. And what is the mass number of sulfur? 32. Therefore, you now write 32 here. You write 32. Then I'll have another one, oxygen. What is the mass number of oxygen? You have 16. And this 4 here is affecting oxygen. And because of that, you're going to write plus 16 times 4. So with this, 1 times 2, 2 plus 32 plus 16 times 4 is going to give me 64. 64. Now in this 64, we are going to say 64 plus 32 plus 2. It will give me now total of 98. This is what we call relative atomic mass. 98 gram. This becomes your answer. That is how to solve relative atomic mass. Now I'll still give you another example. I'm going to have calcium tetraoxosulfate 6, calcium tetraoxosulfate 6, calcium tetraoxosulfate 6. Now, in this case, let me assume now that they did not give you the table. Calcium, Ca, what is the atomic mass? S, what is the atomic mass? Oxygen, what is the atomic mass? So in this case, if you see something of this nature and they ask you to calculate the relative atomic mass, so it's left for you to fathom the mass number of that of calcium. How do I get this? I will get it if I go back and rethink of what we discussed about on atomic number and mass number. We say that atomic number is the number of proton present in the nucleus of an atom of an element. Why the mass number means the sum of the proton number in the atom, in the nucleus of an atom of an element. Now, if it is the sum, which is the mass number we are looking for, since we are looking for the mass number, now check what is the atomic number of calcium, and calcium is the last. Hello, hi, little bearing baby could not offend Flora, neither nag. Magala, sleeper, sick, kissing, Caro. So you now find out that with these 20 elements that I've stated now, calcium is number 20. 20 plus 20, because it says sum of the proton. Summation, when you add them together. And the proton is 20. When you add this 20 again, 20 plus 20 is going to give me what? 40. So with this, if they don't give you this kind of bracket, that is how you can easily get them. Now I'm going to have calcium as what? 40 plus. What of my S? Sulfur. Sulfur, when you go to that first 20 element, sulfur is number 16. 16 plus 16 is going to give me what? 32. And that is why I put 32 here. I have my 32 plus. What of oxygen? Oxygen, they say that the mass number of oxygen is how many? 16. And if you want that 16, you find out that oxygen, the atomic number of oxygen is what? 8. They sum it together to become what? 16. Therefore, 16, which is oxygen. But in this oxygen here, 4 here is affecting that oxygen. Therefore, it must be multiplied by what? 4. Now I'm going to have 40 plus 32 plus 16 times 4, which will give me 64. 64 plus 32 plus 40, 136. Therefore, the relative atomic mass of this calcium tetraoxosulfate 6 become 136 gram. And that is the answer. Very simple. But the fact is that if you don't know all those masses, you find it difficult. That's why I encourage you to know the masses. Now, let us do this high one, because I will give you some cases. You will see a type like this. You have something like sodium or magnesium tetraoxosulfate 6 heptahydrates. That is what to call it. Magnesium tetraoxosulfate 6 heptahydrates. Now, in this heptahydrates, how do you solve the relative atomic mass also? Let's quickly go to the example of that difficult one, as you must have understood this particular method that I use. Now, when they give me magnesium tetraoxosulfate 6 pentahydrate, remember that there is a full stop here, pentahydrate. Why do I call it pentahydrate? Understand your chemistry. In chemistry, we have what we call mono, which is 1, di, which is 2, tri, which is 3, tetra, which is 4, penta, which is 5, hexa, which is 6, hepta, which is 7, octa, which is 8, nona, which is 9, deca, which is 10. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. When I proceed, I can call it monodeca, duodeca, trideca, tetradeca, so on and so forth. Now, magnesium tetraoxo sulfate 6, this 7 here become hepta. 7 become hepta. Octa, which is 8. That is where I derive this 7 here. And that is why I call it pentahydrate. Hydrate means water. And H2O is water in chemistry. Now, how do we solve this one? You have your magnesium. Magnesium is 24 plus X, which is sulfur, 32 plus oxygen, which is 16. 16 times 4 will give me 64. This full stop here still means plus. Now, here you are not going to do plus. You are going to do plus only to hydrogen and oxygen. This 7 that is outside here is affecting all this hydrogen and oxygen. It means 7 multiplied by hydrogen and oxygen. That is what it simply means. Now you put your 7 bracket. What is the mass number of hydrogen? 1. 1 times 2 is going to give me what? 2. You put your plus here. Oxygen is how many? 16. Is there anything multiplying oxygen here? No. You now write 16 here. You close it. 2 plus 16 is going to give me what? 18. And I'm going to have 24, 32 plus 64 plus 7 brackets 18. Now another thing we are going to have to clear the bracket first. So for we to clear the bracket, we are going to have 7 times 18. 7 times 18 it will now give me 126. Therefore I'm going to have 24 plus 32 plus 64 plus 126. That is what I'm going to have. Now 126 plus 64 plus 64 plus 64 plus 32 plus 24. Total is given, the total will be 246 and 246 gram. That is what we call the relative atomic mass. So you can see that this one is different. It's quite different. Why? Because of the penta or the pentahydrate that is attached. They can give you pentahydrate, they can give you tetrahydrate, they can give you trihydrate, they can also give you octahydrate. So it's left for you to use this format to solve it. Now for more clearance, for you to get more clarification, let us just put any other one now. Now among 8, 9 and 10, which one do you want us to choose and solve again before we stop? Okay, number 9. Alright, in this number 9, which is nonahydrate, that is called, that one will answer. Now we can have potassium trioxocarbonate 4 non-hydrate. Look at this one now. Now potassium, what is the mass number of potassium? That is where confusion comes. So you have to go and check. If they give it, no problem. But if they did not give it, you have to use the procedure that I have given to you. Now potassium is 39. Potassium is 39. And 2 is affecting potassium. Therefore 39 times 2 plus. What of carbon? Carbon is 12 plus. What of oxygen? Oxygen is 16 times what? 3, because there is 3 here affecting it. You now put, I told you before that this dot is also what? Plus. Then you have here 9, all in bracket. Hydrogen is how many? 1. 1 times 2 is going to give me what? 2. What of oxygen? Oxygen is 16. There's nothing here that is affecting oxygen. Therefore, you are going to put oxygen like that. Now I'm going to have 39 times 2. I'm going to have 78 here plus 12 plus 64. How do I get 64? 16 times 3. Then plus 9. All in bracket what? 18. Now, for me to clear the bracket, I will use this 9 to multiply the 18. I'm going to have 78 plus 12 plus 64 plus 9 times 18. 162. So I have to add all of them together. 162 plus 64 plus 12 plus 78. 316 gram. And this becomes the relative atomic mass of potassium trioxocarbonate 4 non-hydrates. So that is all about this place. So you have to go further to do more research on their mass number, the atomic number, and also how to solve them. This one is just the most difficult one among them, but I've simplified it by giving you 2 examples. So you can easily solve these ones by checking the atomic number. When you go to sodium, what is the mass number of sodium? 23. The mass number of hydrogen? 1. The mass number of carbon? 12. The mass number of oxygen? 16. 16 multiplied by these 3. These are the things that you are going to have at the tip of your finger, so that you will be able to know how the calculation is. So go for more research to know the relative atomic mass of each and every element.